Hey, youth grade. So today we're going to spend some time working on our physics review to get ready for our test next week. So the first thing we're going to talk about is time versus distance graphs and what story a graph can tell you about an object's motion. So whenever you look at any type of motion graph, it shows an object's motion over time. So in this one, we have distance going across and time going across the bottom. And you'll notice that as time goes by, we go from 0 to 26 kilometers away. And then we stay at 26 kilometers away for about 6 minutes, and then we return. If you're moving forward, it's a positive slope on a distance versus time graph. If you're moving backwards, it would be a negative slope, and this is returning to the start. If you're not moving or you're stopped, there's no slope at all, and it's just strictly a horizontal line. When we talk about speed, we're talking about distance over time. So you can calculate the speed that an object is moving by putting distance over time. And there's a few different ways to manipulate this equation, and the triangle can help you do that. Distance equals speed times time. Time equals distance over speed, and speed equals distance over time. So you'll notice in this triangle that the placement of each of these things doesn't actually change. If you're trying to calculate distance, you see that speed and time are next to each other, and therefore you would multiply. If you're calculating time, you have distance over the top of speed in the triangle, and the same for speed with distance over time. The steeper the line on the graph, the faster the speed. So if the slope is higher, then the speed of the object is faster. So if you were to look at a curved graph of distance versus time, you have an accelerating area where it's got like a downward swoop, a constant acceleration or slope, and then we have a slowing down as it kind of swoops in the other direction, and then a plateau where the object is stationary. So a positive slope or going up the hill is usually indicating acceleration. And a negative slope or going down the hill is showing negative acceleration or deceleration. And a constant speed has no slope and it's a horizontal line. When we talk about the rate of change, we're talking about the velocity of speed over time. And like we said, the steeper the line, the steeper the slope, the faster the rate of change. Velocity is the same thing as speed, but it also has direction added in. So it's a more descriptive word than speed and should be used whenever possible. So you'll notice here we have this constant acceleration on both of the first the part of this line and this line, constant velocity going across the top, and then constant deceleration. And again, on this graph, we have on the red line, a steady speed going forward, a stationary time, and then returning to the start. While this one shows a very fast speed because the slope is higher. And then on this one, we have this curved line, which shows an acceleration. Motion graphs can show an object's speed or velocity over time. Acceleration or moving forward has a positive slope. Negative acceleration or moving backwards has a negative slope. Constant speed or no movement has no slope. Rate rate is talking about the velocity or speed over time. And the steeper the line, the faster the change in rate. So we've seen this distance versus time graph. And now we're going to talk about speed instead of distance. So this is speed versus time. So in a speed versus time, if you have a horizontal line, instead of being stationary, this is actually just a constant speed. And if you have a constant slope, or what looks like a constant speed on a distance graph, you have constant acceleration. Unlike the distance versus time graph, we have steady acceleration, steady speed, gradual acceleration, and then steady deceleration. Go ahead and move on to the rest of your packet today. Once you've finished, you can be on Quizlet.